Hi guys. Afternoon everybody. Just let me know if you can hear me before we start, please. Right. So I normally like to start on time, right? So I see a lot of people still not here. So remember what we're working on right now. We are working on a particular topic called transformations, right? Now, there are 4 kinds of transformations that you are expected to know for your exam, right? The first one is a translation. So that's the first class. That's what we did, right? We spoke about a translation. I showed you how to describe a translation, how to perform a translation, right? The second thing we looked at was a reflection, right? So I told you how to describe a reflection, what they're expecting from you in terms of your answer. And the last thing that we did last week, we were looking at how to perform what we call a rotation, right? Now, we haven't finished rotation as yet. There's one more thing that we need to do with respect to rotation, right? What we did last week, we started with an object, and what we do, we were asked to perform a rotation, right? Whether it's clockwise or anti-clockwise, you need to know the angle, and you also need to know the center of rotation, right? So I kind of showed you the instruments required to do that, and that requires some practice, right? So what we need to do as well, and this is something that I teach my class every single year, right? And the thing is, CSEC has not brought it in a while, but in the January 2023 paper, they brought a question like this, and some students did not know what to do, right? Now, what they can do in an exam question is they can give you an object and they can give you an image. In this case here, we want to locate where is the center of rotation. Now, if you look at this diagram here, right, if the center of rotation is not 0, 0, if it's not the origin, right, we kind of have a problem. We don't know exactly where the center of rotation is, right? Now, could somebody give me one word that describes this object? This is your object here, right? And this here is your image. What's the one word we can use to describe those two shapes there? Put up your hand if you remember. There's a particular word that I'm looking for. I asked it the first thing last week as well. What's the word used to describe this object and this image here? Starts with C. Anybody remember? Unreal?
So is it congruent?
Yeah, those two shapes are congruent. They are identical in all respects. They have the same lengths, they have the same interior angles, right? Now, one of the things about a rotation is that the object and the image, they are congruent, the exact same size. However, the orientation has changed. And that's usually a guide for us to tell us that, hey, this is a rotation, right? Now, if you just look at the diagram by itself here, there's no way you can tell where the center of rotation is, right? Now, to do that, we're going to need some tools to do that, right? So let me just pull up my, make sure you all see in the screen. So. Now, this follows a particular technique here, right? In order to find my center of rotation, right? So these are my object, this is my object, and that's my image, right? And you want to figure out where is the center of rotation. Remember, from the center of rotation, you join in a line from the object to the center of rotation, and then you're rotating it, either clockwise or anti-clockwise. Now, here's what I'm going to do first of all, right? I need to have a ruler. So let me get my tools. I need a ruler, right? I also need a compass in order to do that. So those are the 2 pieces of instruments I need in order to find my center of rotation, right? Now, here's what the procedure is, right? Now, I know you don't have a diagram in front of you, right? So the best thing for you to do here is to probably just look and see what I'm doing here. So we need to join, let's say A and E prime. That's step 1, right? I'm going to join A and E prime. That's my first step, right? So let me get my colors here. Right? That's step 1. I'm going to join E to E prime, right? That's your first step. The second thing that we're going to do, I'm going to join. Now you can use C and C prime, or you can use B and B prime. All you do, you need two lines in order to work this thing out, right? So let's see. I'm going to use B and I'm going to use B prime. Right? I just want you to follow the steps involved here, right? So let me use a different color. Let's use green this time. Right? Now, what some students do, right? They say, well, since we draw these two lines, maybe this is the center of rotation. But that's not true, right? That's not true. So I don't want you to jump to that conclusion that that's your center of rotation. We have to do something else in order to find that. Now, that's step one. You need to join A to A prime, B to B prime, or you could have joined C to C prime. You have options, right? But all I need is two lines in order to determine where the center of rotation is, right? Now, here's what I'm going to do. For each of those lines, the red line and the green line, I'm going to find something called the perpendicular bisector, right? Now, here's how we're going to do this. I'm going to take my compass and let's start with AA prime, right? Let's start with that line. So let's go back to red here, right? And here's what you're going to do. You're going to open your compass, and this is something that you need to remember when you're finding something called a perpendicular bisector. You're going to take your compass and you're going to open your compass so that it is more than half the length of that red line, right? So some students wonder, well, how wide are you opening this? Well, there's a rule that we have to use. It has to be more than half the length of the line, right? So maybe about there is more than half, right? I just want to adjust this a little bit here, right? So what we're going to do, we're going to draw an arc here. I'm going to draw an arc here, right? Next thing you're going to do, with that same opening, you're going to go to the point A. Right? And we're going to draw a second arc here. Right? So that is your first step. Sorry about that. One sec. Yeah, that's your first step there. Right? So what I've done there, I've drawn two arcs, and those arcs allow me to draw what we call my perpendicular bisector. So you see where those two arcs intersect? You're going to take a ruler now. One second. Just shorten this a little bit here. Right? Now, what I'm going to do, I'm going to draw a straight line passing through those 2 points, right? Now, I'm just going to shift the ruler a little bit here because really and truly, the line should be longer than what I've just drawn there, right? But because of how the software works here, right? Now, I want you to understand what I did so far, right? I joined A to A prime, right? What I'm doing, I'm finding something called the perpendicular bisector of AA prime, right? So that is this line here. This line here that I've drawn here, this here is that's the perpendicular bisector of AA prime, right? So we had to do that. Now we're going to do the same thing now, but you're going to do it with the green line. That is BB prime. Now, one thing I'm going to warn you one time is that when you're doing a question like this, what is going to happen is that the diagram is going to get a little messy, right? It is going to get a little messy. And that is where your ability to draw as neat as possible is going to come into play, right? So you're using a sharpened pencil, right? Try not to erase too much on the diagram, right? So what I'm going to do now, I'm going to find the perpendicular bisector of the green line. So let's take that compass here, right? Let's change that color. Let's make it green, right? I'm only using different colors so you can see exactly what I'm doing. So again, we follow the same procedure. You put your pointy part here on B, right? Now you're going to open the compass so that it's more than half the length of the green line, right? So you're going to have to judge that length, right? It doesn't have to be exactly half, just a little more than half and you're good to go. To me, that is looking a little more than half. So what I'm going to do, I'm going to draw an arc here, right? So I'm going to draw an arc here. And all of a sudden, the diagram looks very complicated, right? That's why I'm using different colors here so that you don't get mixed up, right? So that's one. I've drawn the arc there. Next thing I'm going to do with that same opening on the compass, I'm going to go to the point B prime, and I'm going to draw a second arc here, right? All right. Now, all I need now, I need my ruler, and I'm going to draw a straight line passing through those 2 points of intersection of those green arcs. Right? Now, I just want to extend this here because I don't want you to feel that we start at the beginning of the intersection, right? All right. Now, yes, I know the diagram is complicated, right? But what I want you to pay attention to are the perpendicular bisectors that we just worked out. So what I just did there, I worked out the perpendicular bisector, right? Which was this green line here. Now, to get the center of rotation, right, all we do, we actually find the point of intersection of those two perpendicular lines. So you're looking for the intersection of the green line that we just constructed and the red line. Let me see if you're already paying attention here. In the chat, could you all write down the coordinates of the point at which the green line that we just constructed intersects the red line that we constructed just now? Let me see that again. On the diagram, right, the green line that we just constructed and the red line, that's a green straight line and the red straight line, that is this line here and this red line here. Where do those two lines intersect? I want to know what are the coordinates are you all seeing from the diagram? What coordinates are you all seeing on the diagram? Where do those two lines intersect? Try to think, try to think. You're not going for marks, okay, guess, right? But we're looking at the diagram. So I've seen Sanjeev, Jiran, Kevya, Aditya, Hannah, right? Shania. All of them have the same answer, right? T, Nathaniel, right? I've seen a lot of people with the same answer. A lot of people telling me the answer is 3-2. So those of you trying to figure out where these people seeing that, it's right here. Those two lines, they cut at this point here, right? So what we're trying to do is to determine that coordinate. And that coordinate is going to have an X value of 3 and a Y value of 2. So therefore, your center of rotation, right, will have a coordinate given by 3, 2, right? Now, this is something, like I said, I teach this every single year, and it so happened that one came in January 2023, right? That's the first time in a long while I saw them brought that question, right? Now, to really get this, you're going to have to practice it. You have to actually do it. So what you can do, if you look at the class notes, you can draw the two triangles, and you practice it and make sure you can get those two coordinates there, 3, 2. Any questions? No questions? Nobody? It's real easy?
No, sir.
Right? Now I'm going to give you, so I try to cater for students who understand fully what's going on in maths, and I also show students some tricks they can use in the exam if they need to, right? So this is the proper procedure for finding the center of rotation. However, there is another way we can do this, right? There's another way we can do this. If you're running out of time and you're you're struggling to finish the paper, here's a little trick we could do, right? That's not going to copy you. Come back here, right? Here's what you can do. If you're stressed for time in the exam, right, you'll take a compass, right? Now, you could kind of gauge where you can make a guess, right? You can make an educated guess as to where the center of rotation is. Now, we know if I want to rotate the triangle, this triangle here, this one, right? You want on top right hand here. If I want to rotate that, it's going to end up at this point here. But you're kind of looking to see, let's say we look at A and we look at A prime, right? I would probably say, well, maybe the center of rotation is somewhere in this region here. So what you could do, now watch this, we already worked it out and we got 3, 2. But we can test it. Open the compass, right, until you reach the point B here. Now let's rotate this. If I rotate this point B here, about this point, 3, 2, right, B prime should line up exactly. So if you notice something here, B prime is lining up. So that's a good thing, right? So you tested it with B and B prime. So that's working. All right, let's do it with A now. So you open your compass to the point A, right? And then you're going to rotate. If I rotate this here, I should line up by A prime. And you realize, hey, I'm lining up at A prime, right? Do it for C as well. Right, so that's C there. If I rotate this here, watch what's happening. You realize, hey, we lining up here with C prime, right? So if you are stressed in the exam and you're running out of time, right, use your compass and you could kind of guess where the center of rotation is, right? It is not my preferred option for you guys, but if you're running out of time, that's an option you could use, right? Because to do this construction that we just did there, that's going to take students some time, right? And because it's taking them some time here, it's going to be it's going to take you a while to complete this, right? It's going to take you a while to complete this. Everybody okay? Right? So that's the last thing that we had to do with respect to rotation. They can give you the object, they can give you the image, and they can tell you to determine where is the center of rotation. So something like this might be worth maybe 2 marks, 3 marks maximum, right? Right, now we're going to talk about the last type of transformation that you are required to know for the CSEC exam, right? And that is something called an enlargement, right? It's something called an enlargement. Now, when it comes to an enlargement, right, we can take an object and we can increase the size of it. We can scale the size, right? So it can get bigger or it can get smaller, right? So that word enlargement there, right, could be a little misleading, right? Because when you hear enlargement, you're thinking, well, we're getting bigger, right? But I want you to keep in mind that you can actually get smaller as well, right? So you can either increase in size or you can decrease in size. Now, when we did a translation, when we did a reflection, when we did a rotation, we used the word congruent. Both the object and the image were identical in all respects. Same lengths, same angles, right? However, when it comes to an enlargement, the word that we're going to be using this time is called similar, right? So in mathematics, when you use the word similar, it doesn't mean identical, right? When in maths, when we use the word similar, it's not identical. So for example, I have an object here, that's this triangle, and I have an image here. Those two triangles are not congruent. They don't have the same length. Their interior angles are the same, right? But because the lengths are different, they are not congruent. So the word that we use here is similar. So when it comes to similar shapes, the interior angles are the same, but the lengths are different. So this angle here and this angle here, they will be identical. This angle here and this angle here is also identical. This angle and this angle here, they are also identical. That is what we call similar triangles or similar shapes, right? Now, when we are describing an enlargement, there's a special word that we have to say in our answer. And that is something called a scale factor. And that scale factor is represented by a small k, right? So when you're describing an enlargement, you need to tell them exactly what the scale factor is. Now, here's something about a scale factor. It could be less than 0, meaning that it's negative. A scale factor could be greater than 1, meaning that it's positive. A scale factor could also be a fraction, right? It can also be 1 over some number, right? So there are 3 different ways you can express a scale factor. Either it is negative, either it is positive, right? And when I say positive, I mean a positive whole number, or it can be a fraction, right? So that's something we need to know. So that's scale factor. And something else with respect to an enlargement is the center of enlargement. You see, like how we had a center of rotation, you must also specify the center of enlargement, right? Now, let me show you what I mean here. So let's say I have my object, right? This is your object here. That's triangle ABC. And I want to enlarge this triangle, right? And I'm going to get an image here. Now, if I had to describe this transformation, I'm going to say it's an enlargement, right? I must specify the scale factor. So you need to say, what is the scale factor? Right? Scale factor K, and you must specify a number. If you notice the image is bigger than the object, the scale factor is going to be a positive number. Now, to get the scale factor, what you should do is to look at one of the lengths in the object and one of the lengths in the object. One of the lengths in the object and one of the lengths in the image. From my diagram here, could you all put in the chat, what is the length of AB in units? Look at the diagram, and I want you to tell me what is the length of AB in units. What is the length of AB in units? Simple question. You're looking at the diagram and you're trying to tell me how many units is that length AB. That's this length here. This. What is that length? Excellent. Everybody telling me it's 4 units. I am seeing 4 as well, right? So that is 4 units. I agree. Now look at A prime, B prime. From the diagram, what is that length A prime, B prime? Everybody else hearing me? I see Shania saying she's not hearing.
Yes, sir, we are. Yeah.
All right. What you could do, Shania, is just log out and log back in. All right. Okay. All right. So yeah. So my internet bandwidth is extremely high, right? So chances are it could be a problem on your end, right? Yeah, thanks, Lionel, right? Yeah, I realize, yeah, she can't hear me, so she won't hear what I'm saying to do, right? Yeah, so what I want from you all, right? Look at the length. I want to know what's the length A prime, B prime, right? I've seen some answers in the chat, right? I've seen a lot of people saying the answer is A, right? 8, sorry. Everybody saying it's 8. I agree. If you look at this length here, we have 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 units there. So this is 8 here. So if you think about it, AB is originally 4, but after the enlargement, right, that length changes to 8. So what you've done here, you've doubled this. You've multiplied it by a factor of 2. So that's why your scale factor is given by 2, right? So if you double your length, your scale factor is 2. Are you hearing anything there, Shania, now? I hope you are.
Yes, sir, I hear you now.
Okay, good. All right. Yeah, so whenever they ask you about the scale factor, find a length you can measure, right? Because sometimes the diagram might be slanted. So I won't use AC as a length. I won't use BC as a length because I can't measure those things from the diagram. But I can measure the length AB, which is 4 units. I can measure the length A prime, B prime, that's 8 units. So what happened there? You started off with 4 and you jumped to 8. Now with a scale factor, you're always multiplying. You're not adding it, you're multiplying. So 4 multiplied by some scale factor is going to give you 8. So that's going to be 2. 4 by 2 is going to give you 8, right? So that's your scale factor. So certain things they want, if you want to get full marks here, so you must say it's an enlargement. You have to say it has a scale factor k equal to 2, right? But the other thing that we need to specify is something called my center of enlargement, right? Now I'm going to show you how to determine that, which is very easy to do. Now your center of enlargement is similar to how we have center of rotation. It's always a coordinate, right? And what you would do, you would draw what we call projection lines. So B to B prime, A to A prime, C to C prime. All those 3 lines are going to intersect at a particular point. So this point here is your center of enlargement. When you project those lines, they're going to intersect at one point, right? So in this case here, my center of enlargement is 0, -4. That's the coordinate of this point across here, right? Everybody okay so far? Right? Now, like I tell you guys, right? You all know going into Form 4. This is something that Form 5s do, right? And some people struggle with this, right? Some people struggle with this, right? Now, let's talk about so this is scenario 1, right? This is where the scale factor is greater than 1. So there's an increase in size of the object. It gets bigger, right? Now, remember I told you there are 3 different scenarios with respect to the scale factor. Either the scale factor is greater than 1, right? So you have an enlargement, right? The other scenario, or the second scenario, is this. Sometimes the scale factor, right, is going to be a fraction, right? It might be a fraction. And when I say a fraction, it could be a half, it could be a third, right? All I simply mean it's a fraction, right? Now, when your scale factor is a fraction, what happens here is that the image is smaller than the object. So in this case here, this is my object here, right? And this is my image here. So you have a reduction in size, right? You have a reduction in size. But if you have a reduction in size, you have to be careful with your scale factor. Because some students might tell me the scale factor is 2, when in fact it is a half, right? So that is my second possible scenario when it comes to a scale factor, right? Now, everybody cool with this? Let me know. All right, everybody saying okay. All right, now I'm going to give you one here, and I'm not going to spend too much time on it, right? You all know going into Form 4, right? So the third scenario is where we have a negative scale factor. CXC has brought this twice in the past 20 years or something, so, right? Twice. And the last time they brought it, students did not know how to answer that particular question, right? Now, you can have a negative scale factor. And what happens with a negative scale factor is that you have a change in size of the object. And when you look at the image, it looks as if it's a rotation, right? So there's a change in size and the orientation changes, right? Now, like I said, I'm not going to spend too much time on this particular one, right? But just know that there's something called a negative enlargement, right? Now, I'm going to show you something here that you have to know how to do in the actual exam, right? How to perform an actual enlargement, right? So give me a sec here. I want a blank sheet in this. Now, the thing with these questions here is that in order to really understand how to do them, you have to practice it, right? You actually have to do it. At least do one before the real exam and you'll be okay. So here's what we're trying to do here. And this is a typical exam question, right? You want to perform an enlargement on this triangle here, right? What they've done, they've given you the center of enlargement, which is this point here, this point down here. That's O, that's the center of enlargement. And they are telling us that the scale factor is 2. So the scale factor is 2, and you know the center of enlargement, right? Now, since my scale factor is 2, could somebody put up their hand and tell me the image, is it going to be smaller or is it going to be bigger? Up to now, I don't know how to pronounce your name, but go ahead.
Will it be bigger?
It's going to be bigger, right? Once your scale factor is greater than 1, it's going to be bigger, right? Now, what we're going to do, I'm going to show you the procedure in order to do this. And this is something that comes in the exam a lot, right? This actually comes a lot in the exam. So to do this here, right, to perform this enlargement, we need a compass and we need a ruler, right? So here's what you're going to do. Step 1, now you know the center of enlargement. It's this point O here, right? Hey, what happened anyway? That's not. All right, I'm trying to get this as accurate as possible, but sometimes you just can't. So here's what we're going to do. So step 1, you're going to construct what we call projection lines, right? So I'm going to take my ruler and I'm going to start from the center of enlargement, right? That point here, and I'm going to draw a projection line. It's simply a line passing through the center of rotation, right? And it's passing through each of the coordinates of this triangle here. So let's do it for B as well. Right, so I'm going to draw a projection line passing through B. Right, I'm going to do the same thing for the point C. Right, so all you've done, right, all I've done here is drawn some projection lines. That's it, right? Now, there are 2 ways in which I can perform the enlargement, right? I'm going to tell you the 2 of them, but I have a preference, right? Some students, what they do, they will take their ruler, right? So you put your ruler here, and they might do this. Now, the scale factor is required in order for you to be able to do this, right? So your scale factor, K, is equal to 2. That's your scale factor. So therefore, you're doubling your lengths. Right? All your lengths are going to be multiplied by 2. The triangle is twice the size, right? Now, what some students do, they take the ruler and they measure the length from the center of enlargement to, let's say, B. And because the scale factor is 2, they need to double that length, right? But here's the problem. Sometimes when you measure the length, you're going to get you might get something like, in this case, 7.4. And when you double 7.4, sometimes you may plot the wrong point. Right? So that's one way you can locate your A prime, B prime, and C prime, right? However, this is my preferred option, and you can use this if you want. It's up to you. I tend to use the compass, right? Because with the compass, I'm not taking any actual measurement, right? All I'm doing, I'm taking the compass, and I'm going to open the compass, right, to the point B here, right? You open it to the point B here. Now, since the scale factor is 2, right, you're doubling that length that we just opened there. So that length OB, you are doubling that length. So what I will do, since I already have this length here, I will take my compass, I will bring it to the point B, and then I'm going to simply draw, right, a small arc here, right? I'm just going to draw a small arc here, right? Now, that intersection here, or this point here, let me use a different color here. This point here is where B prime is going to be. This point, that's B prime. So that's 1 point on my image. Is everybody good so far?
Yes, sir.
right? Right? So that's B prime. So we're going to do the same thing now, right? For each of the other points. So I'll take my ruler, take my compass, sorry. So let's get the compass again. All right. And I'm going to go to the point O, that's the center of enlargement. Right? But this time I'm going to open the compass only up until the point C here. Right? Now that distance here, now we're going to double that distance. So all you're doing, you take the compass, you rest it here, right? And you're going to draw an arc right here. Right? You don't need to use a compass. You could use a divider if you want as well. That's just to locate where the coordinates are going to be. So therefore, this point here is going to be your C prime. So just like that, I have a C prime and I have a B prime already. Let me ask you all a question. Could you all write down in the chat for me, what are the coordinates of A prime? I want you all to locate A prime for me. That's a vertical line, so you should be able to locate where is A prime for me. Try a thing. Let's see if you get the coordinates of A prime. Where is A prime? All right, I'm seeing a lot of answers in the chat. A lot of people tell me the answer is 1/8, right? That sounds incorrect. That sounds correct. Now let's check and see if that's really correct, right? So I'm not just I'm gonna use the compass again, right? So let's open the compass until we reach the point E. Right? So that's A here, right? Roughly, right? So you're gonna bring this across here, right? So yeah, so it's gonna be around this point here, right? So you all are correct. This here is going to be A prime, right? So to complete this diagram, all you need to do now is to just join those points with a ruler. That's it, right? So if I were to join, let's say C to C prime, sorry, C to B. So this is normally the third question in your exam paper, right? Your CSEC maths exam comprises of 10 questions. And the third question is based on what we're doing here, right? Let's join E. Right? My diagram may not be accurate, but it's to illustrate exactly what we need to do to perform an enlargement, right? And like you all said, right, it is going to be, right, a triangle that's going to be bigger, right? Is everybody okay with this?
Yes, sir.
All right. Now let's try a thing here, right? Feel you all kind of following. Let's look at a typical examination type question here, right? I have two triangles here. Triangle ABC is mapped onto A prime, B prime, C prime, right? By an enlargement of scale factor K, and the center of enlargement is 0, 0. I want you all to put in the chat for me, what is the scale factor? Choose your lengths wisely, and I want you to tell me what is K equal to. Think about it. Watch to see what's happening to your lengths, right? And choose lengths that you can measure, right? I want everybody to try something. All right, I've seen some people saying 2, some people saying 3. All right, now I'm seeing a lot of answers in the chat, right? The majority of you all saying 2. Let's see if that's correct. So if I were to use, let's see, the length, let's look at A prime, B prime, right? Let's look at that length. From the diagram, that's 1, 2, 3, 4, 5, 6. That's 6 units. But on the object, AB is equal to 1, 2, 3 units, right? So your scale factor, right, is actually A prime, B prime over AC. Sorry, AB, my bad. Right, which is 6 over 3, which is equal to 2. So your scale factor should be equal to 2, right? So you can use AB if you want, or you could have used AC as well. On the diagram, A prime, C prime is equal to 4 units, and the actual length AC is equal to 2. So your scale factor is equal to A prime, C prime, that's your image, over your object, which is 4 over 2, which is 2, right? So the scale factor is 2. I'm just curious though, those of you who said 3, right? What happened there? See, Elijah says use AB and A prime, B prime. Right? Just be careful how you're finding. All right, yeah, we're not taking away, we divide it, right? We always divide it, right? Right? Scale factor means you are multiplying by something. So if you look at the lengths, so if this is your object here, the original value is 3, but then it increases to 6. So therefore you multiplied by 2. That's what you did, right? Now this next one here, right? This one is a little trickier, right? This one is a little trickier. I know if you all can get this one. Let's see. I have 2 triangles again, right? A, B, and C is mapped onto A prime, B prime, C prime. What is the scale factor? This one we have no straight lines where you can easily measure the lengths, but you can still figure it out based on how the diagram is drawn. What do you all think the scale factor is? Aha. So this time everybody's saying the same thing, right? Let's see if that's really correct. So a lot of people telling me the answer is K, right? Now, in a scenario like this here, when you look at the diagram, you're going to realize, wait a minute, what really happened here? There's no easy measurement I can make, right? But if you look at, let's say, AC, right? This line AC here is a slanted line, right? But it's slanted, and this is 1 unit here, and this here is 3 units, right? If we go to the diagram and you try to measure, so this is the length AC here. when I come to A prime, C prime, this is the same length. From here to here is also the same length. So you realize that you are multiplying that AC by 3. So your scale factor in this case here, right, just by inspection is going to be equal to 3. Are you guys seeing that?
Yes, sir.
Right? So just by looking at the diagram, even though we have no lengths we can actually measure, you can figure out what the scale factor is, right? Let me show you something here. This one is a CSEC question. This is one that comes in a multiple choice exam. I feel everybody could get this correct. Just put down in the chat, what's the answer? So just put A, B, C, or D. Read it carefully. So that's CSEC question. CSEC repeats all the questions. So let's see if everybody could get this one correct, right? It's a real exam question. All right, let's see what's happening here now. So a lot of people telling me the answer is C, right? Let's see if that's really correct. All right, so when you have a question like this, you have to make sure you know what is the object and what is the image, right? Now they said triangle ABC is mapped onto this triangle here. So therefore, this here represents your object. And therefore, this here represents your image, right? That's your image. So now you want to get a scale factor. So your scale factor, you can choose any lengths on the object and the image. So what I'm going to do, I'm going to use these two lengths here. All right, that's C prime, B prime, right? And you're going to divide that by CB. So C prime, B prime that's a length of 2 units. And CB is only 1 unit. So therefore, this here is going to be 2. Your scale factor has to be 2, right? It has to be a positive number greater than 1, because when you look at the object and the image, you have an enlarged object. Is that making sense? Everybody good? So these are the kinds of questions that come in multiple choice. What I'm going to show you a real exam question here. I think it's 2021, I believe, right? I don't think I have the year written on it. So this is a real exam question here. And usually these questions are worth about 9 marks in the exam, right? So all that we've done so far, this is our 3rd session, right? We've been looking at different kinds of transformations. So they gave them a diagram like this. We have 3 triangles here. We have triangle X. So this is triangle X. This is Y. This is Z, right? Now, I haven't looked at the questions as yet, right? But let me ask you a question here. Could anybody put up their hand and tell me what transformation maps triangle X to triangle Y? What transformation maps triangle X to triangle Y? Anybody could answer that for me? We did 4 kinds of transformations. Shania?
Reflection.
A reflection, right? Now she said reflection, right? But Shania, what if I would have asked you what's a mirror line? What you're going to tell me?
Hello?
Yeah, go ahead. Go ahead.
4.
4. Now remember, the mirror line is an equation, right? There's always an equation. So what they can ask you in the exam, it can be X is equal to something, Y is equal to something, right? It could be an X-axis, it could be a Y-axis. Where you feel it is?
Two, 4.
That's why you broke up a minute. Say it over.
2, 4.
I'm not hearing exactly what you're saying.
Hello?
Yeah, I'm hearing now.
2, 4.
I hear 4. That's all I hear. 4.
Yes, no, sir.
Want you chat as well. All right. So I've seen people saying some stuff in his chat as well. All right. All right. So she says a reflection, and that's good enough, right? She knows it's a reflection, right? Whenever you're doing a reflection, you're folding along a particular line, right? But let's see what the question is asking first. Let's see what they're asking. So this is part 1 of the question for 1 mark. Triangle, so they're telling you that. Triangle X is mapped onto triangle Y by a reflection. That's exactly what Shania said, right? Now what I'm asking you for now, for 1 mark. Now, lots of students got this question wrong because they did not answer the question properly. State the equation of the mirror line. So let's go back to the diagram. What I want you all to do to put in the chat for me, what is the equation of the mirror line? Let me see if you all can get our 1 mark. What is the equation of your mirror line? So a lot of people, right? A lot of people telling me that the answer is X is equal to 0. I think Wilson is the only person saying Y is equal to 0, I think. Now, I know all of you all are looking and you could realize that your mirror line is this line here. I know you all seen that, right? But a lot of you are making a mistake. It is the x-axis, right? This here is your x-axis, right? Now the question asks us, what is the equation? If in the exam you are just put x-axis, CXC will not give you the answer, correct? Right? Because question says, what is the equation? Right? Now a lot of you all telling me it is x is equal to 0. That's not true. Your y-axis is a line y is equal to 0. If you all remember, last week we said that, right? Once and this is how I remember it, it's always the opposite of what you think it is. So your x-axis has an equation and it is y is equal to 0. Your y-axis also has an equation and that is x is equal to 0, right? So if you forgot that, that's something to remember. The equation of your x-axis is this, right? A lot of people just put x-axis here and CXC did not give them the mark for this, right? Because they wanted equation. That's what they wanted, right? So this here is y is equal to 0. That's the answer they want. Everybody good? Making sense? right? Now, the second part here for 2 marks, describe the transformation which maps triangle X to Z. Let's go back to the diagram. Look at the diagram carefully, and we're looking at this triangle here, which is X, and it's being mapped onto Z, right? They want you to describe that transformation as fully as you can. If you think you know the answer, just put it in the chat. What transformation maps triangle X to Z? Right now, I've seen one answer in the chat, right? And that's Sanjeev. Sanjeev, you wanna explain your reasoning? Your answer is correct, right? But I want to know the reasoning. I know you're saying it's a rotation. What is your thinking behind that? Go ahead. I heard the mic come on there. Don't be afraid.
Turn that forward. You point that forward, just turn by 90 degrees.
All right. So you're saying 90 degrees as well. But let me ask you a question. When you look at triangle X and triangle Z, what made you think is a rotation?
Point. Sorry, say.
Okay, without watching the points, right? If you look at the diagram itself, what can you say about the diagram when you look at X and Y? Are they the same size? Are they the same size?
Yeah.
Right, they're the same size. But what you notice about the orientation? It changed, right? Yeah. When you look at X and Z, right, you realize the orientation has changed. Whenever you guys looking for a rotation, right, the size remains the same. So if you look at triangle X and you look at triangle Z, the size is the same. But what has changed though, the orientation of the triangle has changed. So that's a hint to you that, hey, maybe this is a rotation, right? And what you would do, right, what you can do, right, is if I join, let's say I'm using this as my center of rotation, because I can make that assumption. I don't know where it is, but it looks like it's there, right? Now, this point here, if I were to rotate this way, right, this point 0.2 is going to end up here, right? So when I look at it, I can say it is a rotation. Now, remember, what I told you in class is that when you're describing a rotation, there are several things that you have to see, right? So you're going to say rotation, yes. So it's a rotation, right? You must specify the angle. So that angle looks like 90 degrees. If I go back to the diagram, how did I rotate? Did I rotate clockwise or anti-clockwise? Based on what I'm seeing here, I'm rotating anti-clockwise. So it's going to be 90 degrees anti-clockwise, right? and we must specify the center of rotation, right? Now, this point here is the center of rotation, right? Which is 0, 0. So you're going to say, right? So whenever they ask you to describe a transformation fully, and if it's a rotation, these are the 4 things that we have to see. You must specify it's a rotation. You must specify the angle. You must specify whether it's clockwise or anti-clockwise, and you must state what is the center of rotation, right? Is that making sense? Let me know. Because what I want to do, what I want to give you all for homework is I want to give you maybe 2 questions or 3 questions, real exam questions, and we go through the solutions next week. Right? So this is part 2 here, right? They ask us what transformation maps X onto Z. Let's see what else they have here. Now, on the diagram, right, they want you to perform a translation, and you're starting off with triangle Y, and look, they told us what the vector is. And we're going to label that V, right? Now, some of you all, right, as the first thing that we did on the first day of class, right? So we're starting off with triangle Y. So let me just clear this out here first. Review. Right. So what we're doing, we're starting with triangle Y. That's this triangle here, right? Your translation vector, in this case here, right? Just give me 1 second. Yeah, so we starting off a triangle Y, right? And the vector is minus 7, 1. Let's go back here, minus 7, 1. Now, if you all remember, right? I know some people sometimes they forget stuff, right? The number on top tells me if I'm moving to the left or to the right. If I see a negative sign there, it means that I'm moving to the left, right? If I see a positive number here, I'm moving upwards. So what we're going to do, we're going to take each of these points here on triangle Y, and I'm going to perform what we call a translation. So it's 7 units to the left and then 1 unit up. So let's count. 1, 2, 3, 4, 5, 6, 7 units here. And then you're going to go 1 up. So therefore, this here will be my translated point, right? Do the same thing with this one here. So we're going to go 1, 2, 3, 4, 5, 6, 7, and then you're going to go 1 up. So this is where this point is going to be. And the last one, we're going to go 1, 2, 3, 4, 5, 6, 7, and then you're going to go 1 up. So this is where this is going to be. So the image is going to be here. So you take a ruler and you're going to complete this triangle here. Right? So this here is V. Is that making sense? All right, because now let me tell you something here. What CXC does, right? What CXC has been doing within recent times is that in this one transformation question, that one question, they have all 4 transformation in that one question. So if you notice, when we started off the question, the first part of the question was a reflection. So they had reflection in the first part. Then they come and they bring rotation in that same question, right? The next thing that they come and do now here is a translation. So that's the third transformation we need to know. And then what's something? In part 4 now, they come and they say, hey, what? We want to enlarge this triangle, right? We want to enlarge a triangle. The center is 0, 0, and the scale factor is 1/2, right? Now, let me ask you all a question. If your scale factor K is equal to 1/2, is your image going to be larger or is it going to be smaller? Anybody? Is the image going to be larger or is it going to be smaller? Right, everybody's saying smaller. So we know it's going to be smaller. So how are we going to do that now? So which triangle we're using? Triangle X, right? So that's this triangle across here. Now, when you want to perform an enlargement, right, you always have to draw your projection lines, right? Now, the center of rotation and this center of enlargement, sorry, is 0, 0. So so what I would have to do, I would have to take my ruler, right? And I will have to join these 2 points. Right, so this is one projection line here. Then I'm going to draw a second one. Here, let me expand this. Right? Now, to locate where this triangle is, you all already told me that it's going to be a smaller triangle, right? Now, whenever you have, in this case here, the scale factor is 1/2, right? All you need to do, let's say between this point and this point here, right? You're going to find the midpoint or halfway, right? So this here is going to be the coordinates of one of the points of the image triangle. You're going to do the same thing with this line here. From here to here, halfway is going to be this point, right? So I don't need anything fancy to draw this. If I look at this point to this point, halfway is going to be here. So therefore, the image is going to be this small little triangle here. Right? This here is going to represent my image of X after we use a scale factor of 1/2. Right? So you all are correct. It's going to be smaller, right? But you have to be able to draw exactly where this thing is going to be. So this question itself is worth about 9 marks in the real exam, right? Everybody okay? You all find this question was hard? Or was it kind of easy-ish? Right? So what I'm going to do with you in the last class next week, right? What I'm going to do, I'm going to, well, tonight, maybe tonight or tomorrow, I'll send you maybe 2 or 3 real exam questions. I will want you to try it, right? You try it, you try to come up with your answers, and then I'll go through the answers with you guys next week, right? So you'll get a feel for what actually comes in the exam. Normally, what they do, they try to bring all 4 transformations into that one question. Right, Elijah said it's easy once you read it good, right? Unreal, yeah, it's a lot of steps, right? There's a lot of things to remember, right? But once you do enough questions, it's pretty straightforward, right? So, I know 1 or 2 students were asking about continuing classes, right? So my actual new Form 4 class will start at the beginning of August, right? So those of you who want to join that class, you can register online on the platform itself, right? But that class starts in the first week in August, right? And it is this exact same day, actually, Tuesday, 5 to 7, right? So I will send at least 3 questions for you all to look at. I know and the turn test is going on, but if you have the time, please try to do it, right? And I'll go through the answers with you guys next week, right? All right, guys. So that's it for us for this afternoon. I hope you all learned something, all right? And I'll see you guys next week, right? Enjoy the rest of the afternoon, everybody.